Dear students, now let us solve the example problem. Let me read out first. A sphere of aluminium of 0.047 kg is placed for sufficient time in a vessel containing boiling water so that the sphere is at 100 degrees centigrade. It is then immediately transferred to 0.14 kg copper calorimeter containing 0.25 kg of water at 20 degrees centigrade. The temperature of water rises and attains a steady state at 23 degrees centigrade. Calculate the specific heat capacity of aluminium. So, what is the formula? For specific heat capacity, this is the formula. From this, delta Q is equal to ms delta T. Here delta Q represents heat lost or gained. So in this problem, our aluminium sphere has lost the heat and copper calorimeter and water in it gained the heat. I have enclosed a video on this. You see that there what he does in aluminium sphere with a thread. It is kept immersed in water and it is heated until water boils. That is up to 100 degrees centigrade it is heated. Afterwards, a calorimeter is taken. It is, see, there will be copper vessel. In the copper vessel some water is taken and this water is at room temperature and here in the problem it is 20 degrees centigrade. This is made of copper and inside there is water. This copper vessel is kept in a wooden box. There is a hole through which thermometer can be kept to read the temperature. There is another small hole, through that a stirrer is kept. This is moved up and down. The stirrer is moved up and down so that we can have uniform temperature throughout the water. So, and it is covered with a lid. So first what we do? Here we heat the aluminium sphere up to 100 degrees centigrade and then you remove the lid and you send this aluminium sphere into the water. You leave the sphere immersed in the water and immediately you close the lid. So when this is introduced inside the water, here what happens, the aluminum sphere loses its heat to the water, and since the water is contained in calorimeter vessel, so the heat lost by the aluminum sphere is gained by the copper calorimeter and water. Okay, now let us write here heat lost, heat gained. Okay, now which has lost the heat? Aluminum sphere. How much heat is lost by this? For that we have to substitute in the formula. What is required? M means mass of the aluminum sphere. Here only aluminum sphere is losing the heat. And here who is gaining the heat? Copper calorimeter, that is copper vessel. Second, water inside the vessel. Both are gaining the heat energy. Okay, how much heat is lost by the aluminum sphere? What we want? M, mass of the aluminum sphere. It is given 0.047 kg. Specific heat capacity of aluminum sphere, that we are going to determine. Change in temperature. For that first we need initial temperature and final temperature. What is the initial temperature? It is heated up to 100 degrees centigrade. Afterwards only it is sent into this. So this is its initial temperature. So what is the final temperature? It is then immediately transferred to copper calorimeter containing water. The temperature of water rises and attains a steady state at 23 degrees centigrade. So this is the final temperature. Change in temperature. -100 - 23. Okay, so next, copper vessel. For copper vessel also we write mass, specific heat, and initial temperature and final temperature. Mass, it is given here 0.14 kg copper calorimeter. Specific heat capacity of copper, it is available in the table. Copper 386.4. Initial temperature. Copper calorimeter containing 0.25 kg of water at 20 degrees centigrade. This is the initial temperature. Final temperature. See, this is steady state temperature. Change in temperature. TF minus 23 minus 20. 3 degrees. Now water. What is the mass of the water? 0.25 kg. It's a specific heat capacity. See, again, let us go to the table. Water 4186. Next, temperature Ti. Same values. Why same values? Because water is contained in copper vessel. Therefore, both will have same temperature. Now, we have to calculate the heat gained. So, with the help of this formula, we will find out. Delta Q, heat gained, is equal to ms into delta T. M, yes, delta T 3. This is heat gained by copper vessel plus heat gained by water mass specific heat, change in temperature. Now this side, last is equal to mass specific heat, change in temperature. Now we make use of principle of calorimetry. What is the principle of calorimetry? Heat lost is equal to heat gained. So what is the heat lost? What is the heat gained? From this we get specific heat capacity of aluminium. From this we get specific heat capacity of aluminium as this much. So this is the answer, and this is the procedure we follow. A lump of iron of mass 2 kg is heated from 40 degrees to 1000 degrees centigrade. If the heat supplied is 192 kilocalories, find its thermal capacity. Find also the specific heat of iron. Mass, temperature difference, heat supplied, kilocalories means 1000 calories. The calories must be converted into joules. But 1 calorie is equal to 4.2 joules. 1 calorie is equal to 4.2 joules. So we got delta Q value. Now first what is asked? Thermal capacity. Thermal capacity or heat capacity. Both are one and the same. Capital S is equal to delta Q by delta T. Delta T 960. Joule per Kelvin. Here you may say, here actually this is degree centigrade, this is joules. I should write joule per degree centigrade. But here the unit size for Celsius and Kelvin same. Here Celsius is 0, 100. Here 273.15. Here 373.15. Here the difference is 100. Here the difference 100. Here the difference 100. Unit size is same. Therefore, you can write here Kelvin also. Now, specific heat capacity. Small s, that is capital S by M. Mass 2 kg. Joule per kg Kelvin. Two spheres of radii in the ratio 1:2. Specific heats. Two is to 3. Densities 3:4. Find the ratio of thermal capacities. That is capital S1 is to capital S2, that is asked. So what is the formula? S is equal to delta Q by delta T. But delta Q is equal to ms delta T. Here delta T. delta T gets cancelled. So you are getting M into S. Now S1 by S2 is equal to M1 S1 by M2 S2. But density is equal to mass by volume. Volume here sphere volume is 4 by 3 pi r cube. So we write 3m by 4 pi r cube. So rho 1 from this, m is equal to 4 pi rho r cube by 3. Now m1 by m2. m1 by m2 is equal to 4 by 3. These are constants. So here rho 1 by rho 2, here r1 by r2 whole cube. Substituting here, S1 by S2 is equal to M1 by M2 means and here S1 by S2. Substituting the values, rho 1 by rho 2 3 by 4, r1 by r2 1 by 2, s1 by s2 2 by 3, here cube, so that we get 1 by 16, that is 1:16. Two lead spheres at the same temperature have radii in the ratio 1:2. What is the ratio of their heat capacities? See, just now we derived the formula. What is that formula? Let us note that. See, S1 by S2 is equal to rho 1 by rho 2 r1 by r2 cube. Okay, this is the formula. Now first rho 1 by rho 2, is it given? Two lead spheres, same metal, therefore density is same. Densities will be same. Specific heat capacity is same because same metal. Now ratio of radii given. So density is same, 1 by 2 cube, specific heat capacity is same, 1 by 8. Specific heat capacity is defined as thermal capacity by M. Thermal capacity is 8 calories and mass is 10 grams. 1 calorie is equal to 4.2 joules, and here 10 to the power of minus 3 kg, so that we get the answer. "10 liters of hot water at 70 degrees centigrade is mixed with an equal volume of cold water at 20 degrees centigrade. Find the resultant temperature of the water." So here first let me write specific heat formula, specific heat capacity 1 by m into delta Q by delta T. From this we get delta Q is equal to ms delta T, heat lost or heat gained. Formula we have here heat lost, here heat gained. Here 10 liters of hot water. 10 liters or 10 kg, because 1 liter of water is 10 kg water. Only one here item. Here heat gained, equal volume of cold water. So 10 liters or 10 kg of cold water. Hot water loses, cold water gains. Now mass 10 kg. S value change in temperature. It was 70, afterwards resultant temperature, that only asked. So first initial temperature 70, final temperature we don't know. Change in temperature is equal to, see here the temperature is like this, 70, 20, in between it will be there. Okay, now TF minus 70, because this is the hot water temperature. It loses heat, it gains heat, so the resultant temperature will be here. So change in temperature means TF minus 70. Now lost m s delta T. Here mass 10 kg, Ti 20 degrees centigrade, TF don't know. Change in temperature TF minus 20. Gained ms delta T, 10 into TF minus 20. Now by principle of calorimetry, heat lost is equal to heat gained. Heat lost is here 70 minus TF. minus TF, and here TF minus 20. This is higher, this is lower. Take the third side. This is the resultant temperature. Here let me write heat loss or gain ms delta T. Now heat lost, heat gained. Here a liquid of mass m, specific heat S, is heated to a temperature T. This is having lower temperature, this is having higher temperature. It will gain, it will lose. So here mass m by 2, specific heat 2S, temperature 2T. So 2T T here final temperature. So 2T minus TF. Here gained mass m, specific heat S, change in temperature TF minus T. So heat lost is equal to heat gained.